Hi, this is Alex from devstories.eu. OpenAI Agents SDK, Episode 7 of 18. When transferring a customer to a human specialist, you do not force the specialist to read a massive raw transcript of every automated system check that just occurred. You give them a clear reason for the transfer and a clean summary of the problem. Yet, when developers connect AI agents, they often dump the entire raw chat log into the next agent's context window. Today, we fix that by shaping context with handoff inputs and filters. When one agent hands over control to another, it needs a way to communicate why the transfer is happening. You do this using the input type parameter on your handoff routine. You define a schema, typically a pydantic model, specifying exactly what information the receiving agent requires. When the current agent decides to execute the handoff, the underlying language model generates a payload that matches the schema. Let us clear up a common confusion right away. It is easy to mistake this input type for persistent application state, like a user profile ID or a backend database connection that lives throughout the session. It is not. The input type is strictly for transient, model-generated metadata created exactly at the moment of the handoff. For example, if a triage agent hands a user over to a billing specialist, the triage agent might require a field called escalation reason. The triage agent generates a short string explaining the specific billing error, and the billing agent receives that structured data immediately upon waking up. That handles the explicit handover message. Now we must manage the conversation history. By default, the entire message history travels with the handoff. Every user prompt, every assistant reply, and every background tool call gets passed along. This burns through tokens quickly and fills the context window with irrelevant noise. You control this using an input filter. An input filter is a standard Python function that intercepts the conversation history right before the receiving agent reads it. It takes the full list of previous messages as an argument, processes them, and returns a new, modified list of messages. Consider a scenario where your initial agent spent 10 turns calling various search tools and database APIs, trying to resolve an issue before finally giving up and routing the user to a general FAQ agent. The FAQ agent only needs the user's actual questions. It absolutely does not need the raw JSON outputs of 10 failed tool calls. To solve this, you write an input filter function. Inside it, you iterate through the list of incoming messages. You check the role of each message. If the message is a tool execution or a raw tool result, you drop it. If it is a direct user message or a final assistant reply, you append it to your new list. You then return this clean list and attach your filter function to the handoff definition. The FAQ agent now receives a streamlined history containing only the human-readable back and forth. Here's the key insight. Handoff inputs add structured intelligence to the transition, while input filters ruthlessly cut the noise. Together, they shape exactly what the receiving agent knows. You save tokens, reduce latency, and prevent the new agent from hallucinating based on the previous agent's discarded reasoning. Controlling context at the handoff boundary is the single most effective way to keep a multi-agent system fast and accurate. If you want to help keep the show going, you can search for Dev Stories EU on Patreon. Your support means a lot. That's all for this one. Thanks for listening and keep building.